Now let's look at the brain processes behind the common phenomenon of feeling that you almost know the answer to some question but haven't quite got it. In those kind of experiences, we can often supply partial information on the word, like the word rhymes with some other word that we can say, and so forth. So let's use a similar model to before, but add in an area that gets combinations of inputs from the discriminate spoken words area and discriminates between different phrases. And this area could, of course, have played a role in the earlier task as well. Now, suppose the phrase, "a sea mammal with tusks," is heard, and the hearer can't recall the word. Essentially, the same processes as for the retrieval of the capital of France will occur, ending up with the illustrated pattern of column activation. In the tip of the tongue experience, all these columns together don't have a predominant recommendation strength in favor of the speech behavior of saying the target word. So the word walrus can't be spoken, but some subsets of the columns may separately have a strong total speech recommendation strength, so if the outputs of a subset of the areas drives behavior, it may be possible to say things related to the target word. Now, moving on to another basic phenomenon of semantic memory, recognition means identifying objects which have been seen before, and recollection means generating a mental image of previously seen objects and using the image to describe the object. And for human beings, our recognition capability is very much greater than our recall capability. And for example, from earlier in the course, if you were asked to recall the Statue of Liberty, can you remember what it's holding in its hands, what's on its head, what colour is it? But if you're asked, is this familiar, it's much easier. And I mentioned the experiments earlier in the course of people shown lots and lots of photographs and given a few seconds to examine each, and then a week or two later being shown pairs of photos, one from the original set and one new, and asked to pick the one they'd seen before, and being able to do that with about 90% accuracy, although they would have had great difficulty in describing each of the photos they'd seen. So, let's suppose that this is a photo of a place you've never seen before, but a bit later you see it again. Let's think about the first time, and let's use this model for the cortex with different areas combining the visual inputs into more and more complex receptive fields, able to discriminate between more and more complex situations. There'll be lots of receptive fields detected within the visual inputs in the areas that discriminate between visual features. And you will have seen pictures of mountains, lakes, clouds, buildings in the past. So at the level of detailed features, very little will be novel. But at the discriminates visual objects level, the forms of the specific mountains, the forms of the lake and buildings will be more novel, and some receptive field expansions will be required to reach the minimum number of detections in the area. And the juxtaposition of the mountains and clouds, the lake, building and mountain forest, the building and the lake, and so on, will be even more novel, requiring even more receptive field expansions. And lots of receptive field expansions will be needed at the even more complex level. But now think about the next time you see the photo. The visual inputs will require far fewer receptive field expansions, because the previous expansions mean that they'll be detected this time without expansion. There could be a small degree of expansion required. Perhaps the illumination in the viewing room is a bit different. Perhaps if enough time has elapsed, the receptive fields have expanded further during the intervening experiences. Then, because they were firing too often, their thresholds were increased. But in general, the degree of receptive field expansion required will be much less. And this lack of receptive field expansion can itself be detected as a condition. And the condition can acquire recommendation strength in favor of saying the experience is familiar. Another common experience is feeling that a situation that we know to be novel is one that we've somehow experienced before, and we call that a déjà vu experience. How can we understand these types of experiences in terms of what's happening with column activations? Any experience results in a cascade of column receptive field detections across multiple cortical areas. But again, let's just think about the simplified sequence of areas we use to discuss picture familiarity. In almost every experience, there'll be something novel, so there'll be always a degree of receptive field expansion, although it may be very small for a routine occurrence. A completely familiar experience would not require any receptive field expansions, but this is probably rare. A novel experience will generally result in receptive field expansions in many areas, typically more at the more complex levels, because we may have seen similar objects in the past, but their arrangement in groups, and even more so in groups of groups, will have some novelty. Most experiences will have some degree of novelty, therefore, at the more complex levels. But now imagine a novel situation in which, once a fair number of receptive fields have been expanded at the group of objects level, only a small number of receptive field expansions are required at the group of groups level to reach the minimum required. In other words, it happens by coincidence that the combination of receptive fields detected at the group of objects level, including those that expand in order to be detected, define enough receptive fields at the group of groups level to approach the minimum without any expansions at that level. The subjective experience is that activity at different levels of complexity is giving inconsistent indications of the degree of novelty in the experience. This kind of coincidence is relatively rare. It's behaviorally important to be able to discriminate between situations at the more complex levels, but receptive fields are defined heuristically and don't correspond with cognitive circumstances, so these kinds of coincidences can occur. So what we've done is gone through each of these simple semantic memory phenomena and demonstrated how we can understandably account for the phenomena in anatomical terms in a way which allows us to map to more detailed anatomical and more detailed physiological or chemical levels if greater accuracy was required. And after we've covered the other basic memory phenomena, working, episodic, procedural and priming memory types, we'll describe how to understand more complex cognitive phenomena that require long sequences of information processes of multiple memory types.